9.3 is graphing parabolas. So that's something we actually did in chapter 7, but today you're going to learn more about a few different features of a parabola. So as you see in the objective here, it says learn the relationship between the focus, directrix, vertex, and axis of a parabola, and then we'll talk about the equation and graphing as well. So if you read the definition here, it says a parabola is the set of all points equidistant from a fixed line, so a line that doesn't move, it's called the directrix, and a fixed point that's not on the line called the focus. So you can see that right here. Now in class, I'm going to use kind of a cool animated website to show you how exactly this works, but we can get kind of a basic idea here. This, our parabola, which is this curvy line here, is always, every point on it is the same distance from that straight line and the point. So that's pretty easy to see, like right here, the distance between the focus and the parabola is the same as it is on top and bottom. But even if we picked another point, so let's say like this point over here, this distance here, sorry, it's hard for me to make a straight line there, but let me try again. A straight line between those 2 points would be the same distance as a straight line between the parabola and the directrix. So the shortest distance between any 2 points is always a straight line. So if I just keep making straight lines from the point to the focus and the point to the directrix, it'll always be the same. So that's, I'm trying to kind of show you how that's illustrated. It's easier in class to show you kind of an animation of that. So if you want to go online and try the animation for yourself, it's this website here. It's called Desmos.com, and you can choose a parabola and kind of play around with some of these different variables that you see in these equations. So the first equation we have on the left-hand side here is, notice that y is isolated in the equation. So we have y equals, and then the x is the term that's being squared. A parabola like that is either going to face up, like it is here, or depending on our a value, and we'll talk about that in a second, it could face upside down. Notice that's different from when the equation is in the form x equals, and the y is the term that's being squared. Then we have like either a left or right facing parabola. So it could look like the one that you see there, or it could face to the left, either way. Let's look at some of these features again. So you can see the directrix is that fixed line over here and over here, and then the focus is here. The axis of symmetry, that's just on there, that's from chapter 7. Remember that parabolas are always symmetric. So if we go through the vertex and the axis of symmetry, those two things you've heard of before, everything is the same as in chapter 7. So we're just learning about this new focus and directrix, and we didn't do this in chapter 7 either, where it was an x equals. We only did these y equals graphs. Focal width. Focal width is, you see it's written down here, first of all. It is 2p. So first of all, let me define p for you. P is that distance between the directrix and focus, the directrix and vertex, and the vertex and focus. We said it's always going to be equidistant. So we call that distance P. Now we can always get two other points on the parabola called the, using the focal width, and that is we can choose 2 points. There will always be 2 points, 2p away from the focus in either direction. So this distance here is 2p, and this distance here is 2p. And we'll talk about how to calculate what p is, but for now just get an idea of those distances. So I'll draw it on here as well. We have 2p over here and 2p here. So that's called the focal width. And then p is that distance, that equal distance between the directrix and vertex and the vertex and focus. Okay, so here's what you'll want to know. So looking at the equation, let's just look at the y equals equation. So let's look at one that faces up. So I talked about that distance 2p and p. You can see it back on there. Here's some other information we need to know, some of which you've already known. The vertex is the point HK. We talked about that all in chapter 7. Now the focus, we know what it is visually. It's that point that's kind of in between the parabola there. The focus we can always find because it's P away from the vertex, like we said. The directrix is a line. It's a fixed line. It'll also be P away from the vertex. And then we talked about the focal width. The focal width is a way to find 2 more points on the parabola, and we're 2P in either direction from the focus. So that's just kind of summarizing what I said on the first slide. So I said I would tell us how to actually calculate P, and here it is. P equals 1 over 4A, where this A is this coefficient here in our parabola equation. So let's actually start to do some examples. Example 1 is to graph the equation. So we have y squared minus 12x minus 2y plus 25 equals 0. So the first step is to decide which equation we're going to look at. Is this going to be a graph that's y equals and then my x is inside the squared? Or is it the other way around and my x is going to be isolated and my y is going to be what's being squared? Well, it's pretty easy to figure that out. You just look in the problem and you literally look to see which term is being squared. So since y is my square term and x is not being squared, I'm thinking that this is going to be a left-right facing graph. It's going to be x equals something. But it doesn't look like it's in the right form yet, right? So we know the form is x equals y minus h squared plus k. That's what we had on the, nope, I sorry, said that backwards. Y minus k squared plus h. That's what we had on the previous slide. So this formula certainly doesn't look like it's in that form yet. But just like before in chapter 7, the way that you can get it looking like this is by completing the square to get it in that general form. So watch how we do that for this one. So I am going to try to get all of the y's together and square those, and then all of the x's and the other number to the other side. So let me show you what I mean. So y squared, I'm going to write the minus 2y next, because I'm going to take the 12x, negative 12x, and move it to the other side, and the 25 to the other side, leaving some space because I'm going to be completing the square. So I'll add 12x to both sides and subtract 25. So now I complete the square looking at the left-hand side. So looking at my y squared minus 2y. So right here is going to be my b over 2 squared. So b is negative 2 over 2 squared. So that's negative 1 squared, or 1. And whatever we do to one side, we do to the other. So the left-hand side will be a perfect square. That's the whole point. It's y minus 1 squared equals 12x minus 24. So the goal is to get x by itself. That's what we're trying to get it in this general form. So now I'm just going to get x by itself. So I will go ahead and I'm going to factor out minus 1, a 12 on this side. So then I'll get x minus 2, and I'll divide by 12 on both sides to get rid of that. So let me do my work over here a little bit. So right now I have, this is 1/12 y minus 1 squared equals x minus 2, and then I'll just add the 2 to the other side. So let me write it in the correct order. So I'm going to have x equals 1/12 y minus 1 squared plus 2. So what I did then from this step to this step was add the 2 to the other side, and then I just rewrote it with the x on the left-hand side. So now we're in this form. I can see my a is 1/12, my k here is 1, and then my h is 2. So now let's go ahead and find the features that we're going to need to graph. Let's see. I said step 3, find P in order to graph the focus and the directrix. So the formula that I had on the other screen was P equals 1 over 4a. So for this problem, we have p equals 1 over 4, and our a is this coefficient right here, is 1 over 12. So in that case, I'll get 1 over a third, or 3. So we kind of hold on to that because we're going to use that to help us plot some points. Remember that the focal width then is 2 times p. We're going to need that as well. So 2 times 3, or 6. Okay, so let's think about all the features of the parabola that we need now. So we have everything we need, we just need to find each feature. So the vertex, we know, is always hk. So in this problem, the h is on the outside, so that's 2. K is on the inside, so 1. So we have the vertex. So 2, 1, I'm going to put that there. Just like before in chapter 7, our axis of symmetry then is just the line that goes through that vertex. Now remember, we have a parabola that's either facing left or facing right. So the axis of symmetry is horizontal. So that's going to be the equation y equals 1. Okay, now we need that focus, the directrix, and the focal width. So focus and the directrix. And then the focal width will get us 2 more points. So the focus we know from here is p distance away from the vertex. So let me pick a different color here. If we look here at our vertex is at 2, 1, our focus then is 3 away from that. And our directrix is 3 away from that in the other direction. Now, we need to decide, which direction that is, right? So, because we can go 3 in either direction, 1, 2, 3 this way, and 1, 2, 3 this way. But which one is the focus and which one is the directrix? Well, that depends on the direction that the parabola is facing. So, since I know that this a value is positive, this is going to open to the right. Open right. If a was negative, we would, let me write positive a, we would open left. So if this is the case, I know that the focus is the point to the right and the directrix is the line to the left, which I kind of missed. Let me redo that. So there's my directrix and my focus. So I'm already picturing what the parabola looks like. It curves around the focus, but I need at least 2 other points to kind of know exactly how curvy to make that. And that's where we use the focal width. So let me just quickly write down here. The focus was at 5, 1. The directrix was at -1. So now using the focal width of 2p, which is 6, I can just go 6 up and 6 down from my focus, put 2 points, and that'll help me know how to curve my parabola through. So let's do that. Let's go 6 up from the focus. So focal width from the focus. So 1, 2, 3, 4, 5, 6. Then go down 6. 1, 2, 3, 4, 5, 6. And there it is. So this focus, I'll go back over it in blue, and those 2 other blue points are points on the parabola. So now we can go through those points, and we have an idea of how curvy that parabola is. So that's what I'll be looking for in each graph. Focus, vertex, directrix, and then 2 more points using the focal width. Okay, so let's do another. So the first thing we want to do is decide which way this parabola is facing. That helps us get a picture of what's going on. So in this case, the x is the term that's being squared. So right away, I know this is in the form y equals a x minus h squared plus k. So it's going to be a left-right facing, up-down facing graph. Whether we know it's up or down will depend on that a value. So we're going to have to get that and find out if it's positive or negative to figure out if it's up or down. But it's one of those two. So let's complete the square to get it in that general formula. So this time we're completing the square around the x's because we want the x to be the thing in parentheses squared. So I'm going to keep the x terms next to each other. But then I'm going to move the 2y and the 21 to the other side of the equation. So that means we add 2y, we subtract 21. And then we're going to be completing the square with the x values here. So this is our b over 2 squared. So that's 5 over 2 squared, or 25. We add that to both sides. So now the left-hand side is a perfect square. It's x plus 5 squared. And on the right-hand side, when we do negative 21 plus 25, we'll get 4. So we get 2y plus 4. We'll want to factor out that 2 on the right-hand side so that we can divide by 2 on both sides. So I'll go ahead and write dividing by 2 just out in front there because it's going to be our coefficient. That's going to be our a. And then the last thing I need to do is subtract the 2. So I have 1/2 x plus 5 equals y plus 2, but subtract the 2. So I'll write it nicely right here. We have 1/2 x plus 5 squared minus 2. So I'm already picturing a parabola that's facing up. It's going to be opening like this because my a is positive. So let's figure out the p and the 2p so that we can put all the pieces of the puzzle together. So p we get using the formula 1 over 4a. Our a is 1/2. So this is going to be 1 over 4 times 1/2, which is 1/2. So let's hold on to that. And then our focal width is always 2p. So 2 times 1/2 is just 1. So now let's do everything we need. Vertex is always hk. So looking here, the h is in parentheses with the x this time, and the k is on the outside. So that's going to be -5. Remember, think opposite sign. And then -2, same sign. So now we have the vertex. Let's put that in there, -5, -2 right here. I count right, 1, 2, 3, 4, 5. Yep. And then our axis of symmetry, just like in chapter 7, is just the vertical line right through that vertex. Okay, so there's that. I'll make the vertex a little bigger. So now let's get some of the new stuff. The focus and directrix we get just by counting. And we are going to be counting P in either direction of our vertex. So we count P up and P down. So P is 1/2, so we're going to put a point 1/2 up and a point 1/2 down. I'm going to have to zoom in a little for that. So 1/2 up, 1/2 down. So the question is, which is the focus, which is the directrix? But we already know that because we said our parabola was facing up, which means that underneath is the directrix and above is the focus. So I'm going to go ahead and turn that point I made into a line because that's what it is. So that's our directrix. Zoom back out. Let me write that down. So the focus then is at -5, and then we went up 1/2 from -2. So that's -1.5, so -3/2. And our focus is a horizontal line, and we went down 1/2 from -2. So that'll be -5/2. And last thing we need then is to use that focal width to get us 2 points to kind of complete that parabola. So what we do is we go towards the focus. I'll zoom in one more time. And go 2p in either direction. So 2p we said is 1. The focal width is 1. So I'm going to go 1 to the right of my focus and 1 to the left of my focus. So now that vertex and those 2 green points actually make up the parabola. So let me try to do a good job connecting those. So there it is. There's our parabola. In blue above it is the focus. The line behind it is the directrix. And then we have our axis of symmetry on there as well. All right, looks good. So this is kind of the opposite directions. It says write the equation, and then it gives us two pieces of information. So this one gives us where the focus is and where the vertex is. I like to sketch a picture because that helps me to write my equation. So my focus is at 0, 2, so I will put a point there. And my vertex is at 1, 2, so I'll put a point right next to it there. Okay. So let's think about what that means. Let me zoom in a little bit. So we've got these 2 points. We know that the focus is the one at 0, 2. I'll put an F by it so we know. And then the vertex is there. So you already should know what direction this parabola faces. Parabolas curve around the focus. So I already know it faces this direction. I also know my p-value. P is always that spacing in between the focus and the vertex. So the P is just equal to 1, which means I can also figure out that the directrix is just that same distance behind it. So it's 1 behind the vertex. So that's right there. Okay, so that lets me figure out a few things first of all. So if I know, let me zoom out, that my parabola is facing to the left, I know that my equation is in the general form x equals a x minus k squared plus h. Now right away, let's plug in what we know, which is the vertex. That's our h and k. So a y minus k, so plug in the k and plug in the h. So our a we can get once we know what p is, because a is 1 over 4p. Okay, so now hopefully you're seeing why I did all this over here, which was to pay attention to what my p is. Those were one space apart from each other. So I can just plug in p is 1 over here. So then I'm getting that a is 1/4. But there's one other red flag you should be saying here, but Ms. Remmel, our a has to be negative because our parabola opens to the left, and that's true. So we have, putting it all together, x equals negative 1/4, y minus 2 squared plus 1. Okay, same idea, write the equation, but we're given this different information this time. This time we're given the focus and the directrix. Again, I like to just sketch a point to get an idea of like what is actually going on here. So the focus is at 310. So let me put a point there. So here's my focus at 310. And then my directrix is at y equals 4. 1, 2, 3, 4. So I know that my vertex then needs to be halfway in between that, right? So if my focus is up here at 10 and my directrix is down here at 4, I want to land a point directly in between that, which we know would be going, if you just count, 3 in either direction. So if I count down 3 or up 3, so here we have a p of 3. And here we have a p of 3. We can find out where our vertex is. So this is our vertex, and it's the point 3, 7. So let's use that to write the equation. And also, we know that we have an upward facing parabola here because we always curve around the focus. And we never touch the directrix. So we have the general form y equals this time. So y equals a x minus h squared plus k. So the vertex we know, that's our hk. So right away we can plug in our h is 3, our k is 7. We know our a is going to be positive because it's facing up. And to actually calculate it, we know a is 1 over 4p. So 1 over 4 times, we said our p was 3. So it's 1/12. So y equals 1 over 12, x minus 3 squared plus 7. Alrighty, give the homework on Schoology a try. This is lesson 9.3, graphing parabolas.